Hello students, welcome to Narayan PU College online classes. So in the last video, we have discussed about the white phosphorus, red phosphorus and black phosphorus. Clear? So the differences also sometimes they are asking. So that's why at last we have given differences between the white phosphorus and red phosphorus also. Clear? So those are important for some competitive examinations. You have to read each and every point. Clear? And the next concept is here phosphine. Clear ma? So phosphine means what is the formula? We have already discussed hydrides of 15th group element. NH3 we will call as a ammonia, and PH3 we will call as a phosphine, ASH3 or syn, like we have discussed. Clear? So that's why this is the phosphine. Clear? So now preparations and properties we have to write one by one. So first one is preparation methods. Preparation of what it is here, phosphine. First one is preparation method. Clear? So how we will prepare? So the first one is here, first method, by hydrolysis of metal phosphides. Clear ma? Metal phosphides, hydrolysis of metal phosphides. Clear? So previous we have discussed, so when we prepared the ammonia, so hydrolysis of metal nitrides we have discussed. So now instead of nitrides we have to take which one? Metal phosphides. Clear? I will write here calcium phosphide, formula you already know, Ca3 and P2, because phosphorus valence is 3, calcium valence is 2. Hydrolysis, do the hydrolysis with the water or with the acids, acid hydrolysis. Clear? So what you will get? You will get the compound is here phosphine and another one is calcium hydroxide. Clear ma here? You know that balance here, how many phosphorus atoms are there? 2. So multiply this one with the 2. How many calcium atoms are there? 3. So multiply here with the 3. Then balance here hydrogens, 2 into 3, 6. 3 into 2, 6. Total how much? 12. 12 means I have to take here 6 molecules. This is with the water. With the acid also you can write. Take the same calcium phosphide. What is the name of this one? Calcium phosphide. Treat this one with the HCl. Treat this one with the what? It is HCl. Then you already know what it is here, and you will get the calcium. Previous OH is there, you will get hydroxide. Now it is chlorine is there, you will get the calcium chloride, Ca, Cl2, plus what you will get? Phosphine. Phosphorus will combine with hydrogen, calcium will combine with chlorine. Clear? So balance again here 2 phosphorus and 3 calcium atoms are there. Now balance here hydrogens and chlorine, 2 into 3, 6 hydrogens, 3 into 2, 6 chlorines. So that's why multiply this one with the 6. You will get the compound is what it is here, phosphine. This is one preparation. Second preparation is laboratory method. Clear ma? So laboratory method. Clear? So this we have already discussed in the last class. Clear ma? So laboratory method. Clear? So we have discussed it already. Clear ma? What is the laboratory method means? Take the white phosphorus and treated the white phosphorus with the concentrate NaOH solution. Then you will get the phosphine and sodium phosphite. Clear ma? So that is laboratory preparation of which one ma here? Laboratory method for the which one here? So laboratory method for phosphine. Clear ma? Right here. So what it is? Phosphorus. Which phosphorus you have to take? White phosphorus. Why? Because white phosphorus is very reactive. So that's why. And treat this one with the NaOH. Treat this one with the NaOH and solution, concentrate NaOH solution. Red phosphorus will not react with the NaOH. Clear ma? So that's why take the phosphorus and NaOH. What you will get the compound ma here? You will get the compound is PH3 NaH2 PO2. I already mentioned this is what it is ma? Sodium phosphite. What is the name of this compound ma? Sodium phosphite. Clear? So balance here, you know how to balance, I have already mentioned previous. Clear ma? So again I will not discuss 3 and 3. See in the first year how to balance the, you know, disproportionation reactions. Clear? It will be there. Based on that you can do this, you know, balancing. And next one is here pH3 is there, and balance the phosphorus atoms here. 3 nitrogen atoms are there, and you know in this one what the compound you will get, phosphorus P4, 4 phosphorus atoms are there, 3 sodium atoms are there. So I will multiply this one with the 3, because this side 3 sodium atoms and here 3 sodium atoms. Total how many ma? The 3. So that's why total here phosphorus atoms 3 and 1 4. It is balanced. Clear ma? So this is very important reaction for your PU examination also. Clear? Sometimes they are asking this question. Clear ma? So this is about the, what it is ma here, laboratory method. And the third method is there. Clear ma? So what is the third method is from phosphonium salts. Clear ma? Phosphonium chloride, halides, whatever may be. From phosphonium, ammonium, like ammonium salts we will say, phosphonium salts. Clear ma? Phosphonium salts. Clear? So what it is there, here I will take and pH4 and I will write here iodine, phosphonium iodide. Clear ma? What it is here, NH4I, what we will call, NH4Cl, what we will call, ammonium chloride, and NH4I, ammonium iodide. In the same way phosphonium iodide. Clear ma? Phosphonium iodide. This is clear, and it is treated with what it is ma here, and if you heat this compound, clear, then what you will get here, see, you will get the compound is, or treat this one with the alkali, with the what it is ma here, alkali, KOH. Alkali means what it is ma, using the base, then what the compound you will get, you see, potassium and iodine will be removed as a Ki. Clear ma? And OH and 1H will be removed as a, you know, H2O. Then what you will get ma? Only pH3 will be there, that you will write here phosphine. So we are preparing phosphine or not ma? That is clear. So by using this reaction, because you will get what the phosphine you will get is very pure. Why I am saying here is, you know that phosphine always contaminated with diphosphine, P2H4. What we will call ma, this is diphosphine, always contaminated with diphosphine, which is highly flammable, which is what it is ma here, highly, you know, highly flammable, means it catch fire easily. So that's why if pH3 is always contaminated with, pH3 is contaminated with diphosphine, so that's why if diphosphine is there and this phosphine catch fire in the air. Why? Because P2H4 is highly flammable. Clear ma? So that's why it catch fire, so that's why automatically pH3 also, you know, it burns. So that's why what we have to do while preparing the pH3, you should remove the P2H4, means what it is ma, diphosphine. So how to remove that diphosphine means, here take the phosphine here, phosphine mixture, it will have, it contains, always phosphine is contaminated with which one ma, P2H4. Clear? P2H4 means it is a impurity, like you can say impurity. Clear? So then treat this one with the HI. Here also which one is there ma? Impure P2H4 is also present in the pH3, but when treated with HI, only pH3 will react with HI, converted into pH4I. Clear ma? So pH4 high, now impurity is there here, and remove pH4I, it is you know, only pH3 will react with HI, not the P2H4. pH3 will be converted into pH4I and impurity will be present here only, and remove this, you will get the, what it is ma here, pure pH4I, that is phosphonium iodide. Now treat this one with the KOH, then you will get the pure, it won't be contaminated any P2H4. Clear ma? So that's why we have to do, first of all, treat this one with the HI, then you will get the pure phosphonium amiodide, and that will treated with the alkali, you will get the very pure phosphine which not contaminated with diphosphine. Clear ma? So these are about the 3 preparation methods of which one ma here, phosphine. So next we will discuss about the structure of phosphine. Clear ma? Next one is structure of pH3. Clear? So you already know, we have discussed already about the structure of pH3. Clear? So you know that pH3 means, you know, phosphorus is forming how many bonds? 3 bonds means, 3 bonds means it will have 3 bond pairs, and also it will have 1 lone pair. Clear ma? So that's why, what is the central atom? What is the phosphorus hybridization? You know that hybridization of phosphorus in, what it is ma here, pH3. What is the hybridization ma? 3 plus 1, 3 plus 3 lone pairs and 1 bond pair, 3 plus 1 4. 4 means what it is ma? sp3. Clear ma? So how many bond pairs are there here? There are 3 bond pairs plus 1 lone pair. So that's why hybridization is 3. If bond pair is 3, 1 lone pair 1, what is the shape here? Shape of the molecule is pyramidal. What is the shape ma? Pyramidal shape. Clear ma? So that is means, if you take here phosphine, there will be a hydrogen, and here hydrogen and hydrogen, and there will be a 1 lone pair of electrons, and here the bond angle is 93.6 degree. We have already discussed. Clear ma? So this is about the structure of which one ma here? Structure of, you know, phosphine. Clear ma? Next one, physical properties. If I write here physical properties. Clear? So what are the physical properties means? Clear? So it is a colorless gas with a rotten fish smell. Clear ma? So what is the first one here? It is colorless gas. Colorless, you know, gas with what ma here? Rotten, R-O-T-T-E-N, a rotten fish smell. Clear ma? That is, and you know, this is slightly soluble in water. Why? Because ammonia easily means ammonia highly soluble in water. Why? Because it can form a hydrogen bonds with the water molecule, but it cannot. So that's why it is slightly soluble. It is slightly soluble in water. It is slightly soluble in water. Clear ma? So it is soluble in, clear ma? Soluble in, clear ma? Organic means mainly CS2, carbon disulfide, and organic solvents. Clear ma? So this is about the, what it is ma here, physical and properties of phosphine and structure. Clear ma? So next we will discuss chemical properties. So next one is chemical properties. Clear ma? Chemical properties. Clear? So first one is chemical properties, basic nature. What it is ma here? Basic nature. Clear? You know that I already mentioned, and all hydrates of 15th group element, ammonia, phosphine, arsine, you know, stibine and bismuthine, all will have the lone pair of electrons on their heads. Clear ma? So they are having one lone pair of electron, so that's why they can donate the pair of lone pair of electrons to others. You know that according to the Lewis acid base theory, lone pair donor we will called as a base. So that's why this phosphine is Lewis base, so that's why it can react with the, you know, mineral acids to give the salts. Clear ma here? So what is that reaction? You know, simple previous we have already discussed, and pH3 and treated with the HX. halogen acids or hydrogen halides. Clear ma? So what you will get here, you know, it is a Lewis base and it is a acid base and acid, you will get the salt plus water, but water you will not get because we are taking here HX. Clear ma? So that's why salt you will get. What is the salt you will get ma? You will get PH4X, phosphonium halides. What you will get ma here? Phosphonium halides. Clear ma? This is phosphonium halides. Clear ma? And the same way, means I will take one example here. I will take PH3. Just now only we have mentioned here HI, and you know PH3 always contaminated with diphosphine. When we pass through HI, only PH3 will react with HI and gives the what it is ma? PH4I, pure PH4I. Now it will treat it with the KOH, we will get the phosphine that we have already discussed. Clear ma? So this is first reaction, basic character. Clear ma? Next, second one is decomposition. Clear ma? So this is, what is the decomposition means here? The solution of, you know, phosphine in water decomposes in the presence of light and gives the red phosphorus and hydrogen. Red phosphorus and which one here? Hydrogen. What it is here? Solution of, clear ma? Solution of phosphine in water, solution of phosphine in water decomposes in presence of light, in presence of which one ma here? Light, to give which one? Red phosphorus and hydrogen gas. Take here phosphine. Clear ma? Here phosphine, which one here? Solution. Clear ma? And heat this. Clear? You will get the phosphorus and which one ma? Hydrogen gas. Which phosphorus you will get here? Very important, red phosphorus, not the white phosphorus. Clear? So why if you see white phosphorus means aqueous solution, it is very highly reactive. So that's why balance here. How many phosphorus atoms are there? 4. And how many hydrogens are there here? 12. 12 means here I have to put here 6. Clear ma? So this is the second reaction. Clear ma? And third one is reaction with chlorine. Third one is reaction with which one ma here? Chlorine. So what is the reaction with chlorine? You know that phosphine when reacted with chlorine in the limited amount or excess amount, and it gives the and respective phosphorus halides, phosphorus trihalides and phosphorus pentahalides. Clear ma? Simple. You take here phosphine, take the phosphine and treat this one with the chlorine. Then what the compound you will get? You see ma? You will get the one is phosphorus trichloride. Clear ma? And H is there. H and Cl will be removed as a HCl. Now balance here reaction. How to balance the reaction here? How many chlorine atoms are there? You know, hydrogen atoms are there here 3, and here how many hydrogen atoms are there? You know, and here 1. So multiply this one with the 3. So how many chlorine atoms are there? 6. 3 plus 3, 6. So that's why you have to take here 3 chlorine atoms. Clear ma? And if you take 3 moles of chlorine atom, you will get the PCl3. And if you take excess amount of chlorine, then you will get the PCl5. So that also I will write here. PH3 when reacted with the chlorine. Clear ma? So what you will get here? You will get the PCl5 plus what it is ma? HCl. Clear? Now balance here. And chlorine atoms, how many? 3 hydrogens, 3 are there. So I will put first of all 3, then 3 hydrogen atoms are there. Total how many chlorines? 5 plus 3, 8. 8 means I have to put here 4. Clear ma? If I take 3 moles of chlorine atom, you will get the PCl3. If you take 4 moles of chlorine atom, you will get the PCl5. That is the reaction with what it is ma here? PCl3. Next one is reaction with metallic salt solutions. Fourth one, very important this is. Clear ma? Fourth one is reaction with metallic salt solutions. Clear ma? That is clear. So what is this metallic salt solutions? Whenever phosphine gas is passed through the solutions of copper and mercury salt solutions and precipitate them into their respective phosphides. Clear ma? So what the reaction we will see. See what happened here, when phosphine gas is passed through the solution of copper and metal salts, and these metal salts are converted into respective metal phosphides. Clear? Simple, I will write here example. First one is, I will take the copper sulfate salt solution. Clear ma? And to this salt solution we will pass the phosphine. We will pass the which one ma here? Phosphine gas. Then what happen, you see, copper and phosphorus, you will get the metal phosphides, you will get. Metal is there, so what is the metal phosphides ma? Cu3 and P2 plus remaining what it is there ma? H is there, SO4 is there. It will be removed as a H2SO4. That is. Clear ma? So balance the equation. How many copper atoms are there? 3. So I will multiply this one with the 3. And here how many phosphorus atoms are there? 2. I will multiply this one with the 2. Then how many hydrogens are there here? 6 hydrogens are there and 3 sulfate atoms are there. I will multiply this one with the 3 and it is balanced. So what you are getting here? You are getting metal, phosphides precipitate. Clear? In the same way, take here mercury chloride. I have taken sulfide here. Now I will take mercury chloride. Mercury chloride if I take and treat this one with the same, with the phosphine, and pass the phosphine gas through the aqueous solution of, this is what it is ma? Aqueous solution of, clear, Hg2Cl2. Then what you will get ma? You will get the compound is Hg3P2 plus, now here hydrogen and chlorine, previous hydrogen and SO4, H2SO4, hydrogen and chlorine, you will get what it is ma here? HCl. Clear? Then see balance here, same 3 moles here and 2 moles, totally 6 hydrogens and 6 chlorine, so this is HCl. Clear no? So these are about the four chemical properties of which one ma here? Phosphine. First one is basic nature, decomposition, reaction with chlorine. This is important, reaction with metallic salt solutions. Next one is uses of phosphine. Clear ma? So the main use of phosphine is here as a Holmes signals, clear, in deep sea or oceans for signaling the danger points to the steamers. Clear ma? So any danger points are there in the oceans, and the two signaling those dangerous point to the steamers, and this is used as a phosphine is used as a what it is ma here? Holmes signals. Clear? So how it will work? Clear? So what they will do, the containers containing calcium phosphide, mixture of what it is ma here? Calcium phosphide. What is the formula of calcium phosphide? Ca3P2, and another one is calcium carbide. Clear? The containers containing mixture of calcium phosphide and calcium carbide and pierced and thrown into the sea. Clear ma? So then what will happen? And when the bag, the container is contact with water, clear ma? So then what will happen? When water is contacted with calcium phosphide, calcium phosphide reaction with water, what you will get ma? Phosphine. What is the product you will get? Phosphine. Clear ma? And here also it will combined react with water, calcium carbide react with water. In the first year you have studied already ethylene, clear ma? Acetylene you can say. You will get the acetylene, C2H2. Clear ma? As I already mentioned, phosphine is not a pure one. It is always contaminated with the diphosphine, P2H4, which is highly flammable. So that's why in this phosphine small amount of diphosphine is present, so it catch fire immediately, and due to that, and pH3 also burns. pH3 also what it is ma here? Burns. So what will happen here? When pH3 burns, and this ignites the C2H2, acetylene gas. Clear? So and it ignites and it burns with the luminous light. Clear ma? It burns with very glow, means luminous light, and which serves as a signals for the steamers. Clear ma? So this is the what it is ma first use of what it is ma here phosphine. Signals here for the to signaling the danger points for the steamers, and what they will do in a container, in a small bag, they will keep the calcium phosphide and calcium carbide, and pierced and they thrown into the sea. They throw into the sea. Then what will happen? And when it is contact with water, calcium phosphide is converted into phosphine, and calcium carbide is converted into acetylene. And this phosphine always contaminated with the diphosphine, so that's why it automatically catch fire, and this fire and ignites the acetylene, and it burns with the luminous light, and it serves as a signals for the stamens. Clear? This is the first use of what it is here, phosphine. Clear? And next one, and here for the production of smoke screens, mainly this is used in during the war. Clear? So that the shells containing the calcium phosphides and are exploded by the warships. Clear? So what will happen in those cells, and when war takes place between the two countries, then mainly they will use this one. Clear? And in that shells the containing the calcium phosphide, they will fill the shells with the calcium phosphide and they will explode. Then what will happen here? And it will come into the atmosphere. When the calcium phosphide and comes into the atmosphere, and it will react with the moisture and will be turned into what it is here, phosphine. Turn into phosphine, and this phosphine react with the oxygen which is present in the air and converted into which one? Phosphorus pentoxide. And phosphorus pentoxide means, yesterday I already mentioned, it gives the white dense fumes, and that act as a smoke screen. Totally there will be a totally smoke will occupy that space, so that's why we cannot see others. Clear? So that is the main two uses of here phosphine. And next we will go for here phosphorus halides. Next concept is here phosphine we have completed, and the next one is phosphorus halides. Clear? That, and 15th group elements mainly forms two types of halides. One is the phosphorus trihalide, and another one is phosphorus pentahalides. Clear? So that PCl3 and PCl5 we have discussed, right? So in this one, first we will discuss about the phosphorus trihalides, and after then we will go for the phosphorus pentahalides. Put the heading here is phosphorus trihalide. In that one, first one is mainly we will discuss about the phosphorus trichlorides. Clear? So put the heading phosphorus trichloride. Phosphorus trichloride. What is the formula? Phosphorus trichloride, PCl3. This is the formula. Clear? So now write the first one, preparations. First one is preparation methods. Preparations. Clear? We have two preparations here. The first one is laboratory preparation. Clear? So in the laboratory preparation, in the laboratory preparation here, clear? So in the laboratory preparation, and what is there, first one is we will directly take the phosphorus and chlorine. Phosphorus and what it is here, chlorine, and directly, so here RATORY, sorry, write the spelling correctly. Laboratory, so BORATORY, laboratory preparation. Clear? So what is the laboratory preparation? What we will do, take the white phosphorus. We will take most of the time which phosphorus here? White phosphorus, not the red phosphorus. Why? Red phosphorus is less reactive. It will take time to react. So that's why what we will take here, take the phosphorus. Which phosphorus here? White phosphorus. Take the white phosphorus and treat this one with the chlorine, because we need which one? Chloride. So that's why treat this one with the chlorine. Then what you will get? You will get the compound is PCl3. Clear? So balance the equation. How many phosphorus atoms are there? 4, and multiply this one with the 4. How many chlorine atoms are there? 12. 4 into 3, 12. So multiply this one with the 6. This is the laboratory preparation of which one here? Phosphorus trichloride. And the second one is Second one is from thionyl chloride, from thionyl chloride. Clear ma? So next one is from thionyl chloride. Clear? So what is this thionyl chloride? You know that. Take the same here, white phosphorus. Take the white phosphorus. Which phosphorus ma here? White phosphorus, and treat that one with the thionyl chloride. You know what is the formula of thionyl chloride? SOCl2. Then what the compound you will get ma? You will get the compound is PCl3 plus SO2 plus what you will get ma? S2Cl2. Sulfur monochloride along with sulfur dioxide. You will get the S2Cl2. Balance the equation. You know how to balance the equation. This is what it is, 0 and here plus 3. 0, 2 plus 3. What is the change here? 3, but for phosphorus 3. But how many phosphorus are there? 4. And this is 12. And you know this is plus 4. Clear ma? So minus 2 and minus 2 plus 4. This is also plus 4. Clear ma? It won't be changed. And here this is a plus 1. Clear ma? So then what it is? Plus 4 to plus 1. How much difference is there here? 3 units decrease is there. But for one sulfur, but how many sulfurs are there? 2. So here 6. Here how much is there? 12. Here 6. So this equation you have to multiply with the 2. Clear ma? Then I will write here. This is multiplied with the 2 and this is also multiplied with the 2. Why? Because here it is not changed. So that's why you no need to multiply. Clear ma? Then what happened you see? And if you balance here, phosphorus how many atoms are there? 4. So that's why I will multiply this one with the 4 first of all. Clear ma? Then you see, and here I multiplied this one with the 2, and here sulfur how many atoms are there? You once you check it. Otherwise chlorines you see 4 into 3 12. 12 plus 4 16 are there. But here how many are there? 2 or 4 are there. So that's why I will multiply this one with the 8. 8 into 2 16. Clear ma? Now it is automatically balanced. Sulfur how many atoms are there here? 8 sulfurs are there. And here how many sulfurs are there? 4. So that's why I multiply this one with the 4. Clear ma? So these are the preparations of which one ma here? Phosphorus trichloride. Clear ma? Next one. Structure of PCl3. Clear ma? Same what we have discussed about the pH3. Instead of hydrogens, what are there ma here? Instead of hydrogens, we have the chlorine atoms are there here. Clear ma? So that's why take here what is the hybridization of phosphorus here? Phosphorus hybridization is sp3 because 3 bond pairs and 1 lone pair. How many bond pairs are there? 3 bond pairs plus 1 lone pair. 1 lone pair and 3 bond pairs. Then 3 plus 1 4. 4 means what is my sp3? 3 bond pairs and 1 lone pair. You know what is the structure of this compound? And pyramidal. The structure of the shape of this molecule is pyramidal shape. What is the pyramidal shape ma here? Pyramidal shape means this is. Clear ma? Same chlorine atoms will come here, chlorine, and here there will be a chlorine and there is a lone pair of electrons here. Clear ma? So this is about the preparation and preparation and structure. And the next one is what are the physical properties? Clear ma? So I will write here 2 physical properties are there. Physical properties. Clear ma? So physical properties. Put the heading here, physical properties. Clear ma? It is a liquid. It is a colorless, pungent smelling liquid. Clear ma? So what it is here? It is, first point, it is colorless. Clear ma? Pungent smell. Pungent smell liquid. Pungent smell, what it is ma here? Pungent smell liquid. And second one, it fumes in moist air. It fumes in moist air. And these are the liquid. It is important. Sometimes what it is there, PCl5 is it is a solid, yellow color solid. It is a liquid, oily liquid it is. Clear ma? So whenever some questions are there, they will not give one compound is reacted with the chlorine and it gives the oily liquid. Clear ma? Liquid they have given means that compound is a PCl3. If they give that is a yellow solid or crystal, then it is a PCl5. Like that questions are there, you have to be. This is about the physical properties, preparation and structure. Next one is chemical properties of PCl3. Clear ma? We have discussed about the first one preparation methods, two preparation methods we have completed, and the second one we have discussed about the structure of the compound, and the next one is physical properties. Mainly two are there. It is a PCl3 is a and colorless, pungent smelling liquid it is. Clear ma? And it fumes in moist air. Clear? And next one is chemical properties. The first one is reaction with water. This is very important reaction ma, reaction with water. Clear ma? So what is the reaction? Means PCl3 when it is reacted with water, what the compound you will get. Clear? So when PCl3 is reacted with the water, it will give the phosphorus acid plus HCl. What you will get here? Phosphorus acid. Very important. PCl3 hydrolysis, you will get the phosphorus acid. Clear ma? And PCl5 hydrolysis, you will get the phosphoric acid, H3PO4. It is what it is ma here? Phosphorus acid. It is a phosphorus acid. Clear? H3PO3. When if I take the PCl5 hydrolysis, you will get the H3PO4 phosphoric acid. Clear ma? It is in +3. +3 means as acid you will get. Phosphorus in +5 oxidation means ic acid. It is a phosphorus acid. PCl5 means oxidation state of phosphorus how much? 5. When it hydrolysis, it gives ic acid. Ic acid means phosphoric acid, H3PO4. That we will discuss later. Clear ma? And the next one is here reaction with. Next one reaction with chlorine, oxygen and sulfur. Reaction with what it is ma here? Chlorine, oxygen and sulfur. And first one PCl3 reacted with the chlorine, what the compound you will get ma? You will get the PCl5. PCl3 plus Cl2, add PCl5. And the next one treated this one with the oxygen, PCl3 plus oxygen, what you will get ma? POCl3, phosphorus oxychloride. What is the name of this compound? Phosphorus oxychloride. Phosphorus oxychloride. Clear ma? So this is how many moles oxygens are there? 2. So that's why I have to multiply this one with the 2. I have to multiply this one with the 2. So next one same here. PCl3 when reacted with sulfur. PCl3 when reacted with sulfur, it will gives the PSCl3, thiophosphorus oxychloride. What is the name here? Thiophosphorus oxychloride. Clear? Simple. Why? Because here instead of O, what is there ma? Sulfur. If sulfur is there, we will call this one what it is ma? Thio. So that's why thiophosphorus oxychloride. And this is reaction with what it is ma here? Reaction with and chlorine, oxygen and sulfur. Next one very important here, reaction with organic compounds. Reaction with organic compounds containing what it is ma here? Containing OH group. This is clear ma? Reaction with organic compounds containing which group ma here? OH group. This is important. OH group. We have already discussed it so many times, this reaction. Clear ma? So what is that one here is suppose I will write here OH group. OH group means what is ma? Alcohol can I write or not? Yes, you can write. Suppose if I write CH3 CH2 OH and treated with the PCl3, this reaction we have studied already in the haloalkanes and haloarenes. Clear ma? So what is the reaction here? And 1 mole of PCl3 will react with the 3 moles of alcohol. Clear ma? 3 OH groups will be replaced by 3 3 OH groups are replaced by 3 chlorine atoms, then I will simply write C2H5 3 moles and Cl. What you will get ma? Here 3 OHs are there and phosphorus left here, so that's why H3PO3. That is what it is. You will get phosphorus acid. Clear? In the same way, and not only with the alcohol, treat this one with the CH3CO OH also. Take the CH3CO OH, then what the compound you will get? You will get treated with the PCl3 and take 3 moles here. You will get the compound is 3 moles of CH3CO and Cl plus what you will get? H3PO3. H3PO3. Clear? In the same way, if you take any benzene sulfonic acid and benzene sulfonic acid, this is benzene sulfonic acid, treat this one with the PCl3. How many moles I have to take? 3 moles. Then what the compound you will get? You will get the benzene sulfonyl chloride. Benzene Hinsberg reagent we will call this is, we will discuss H3PO3. What it is here? Benzene sulfonyl chloride. See, in all cases OH group is converted into what it is halogen groups. Clear So this is what it is reactions of PCl3. Reaction with water, reaction with chlorine, oxygen and sulfur, and reaction with organic compounds containing OH group. And last one is here uses. Clear? What is the main use means? Main use of this PCl3 is conversion of what it is here? Conversion of OH group into Cl group. OH group into what it is here? Cl group. This is the main use of this PCl3. Means you see, alcohols are converted into alkyl halides, acids are converted into acid chlorides, and sulfonic acid is converted into sulfonyl chloride. So this is about the what it is here? Phosphorus trichloride. Next one is here phosphorus trichloride we have already completed, and the next one is what it is here? Phosphorus pentachloride. Pentachloride means what is the formula? PCl5. First, as usual, we will discuss about preparation methods. Preparations. Clear? So the first preparation is clear, and phosphorus, white phosphorus react with the excess amount of the chlorine and gives the PCl5, or you can directly take PCl3 trichlorides, phosphorus trichloride react with chlorine and you will get the PCl5. That previous we have already discussed. Reaction of PCl5 with the chlorine, oxygen and sulfur we have discussed there. PCl3 react with chlorine, what you are getting? PCl5. That method also can be taken. So what is the first method here is white phosphorus. You take always white phosphorus, clear and treat this one with the chlorine and heat it. Then what you will get you will get the compound is PCl5. Clear? So how you balancing? 4 phosphorus atoms are there, 4 into 5 chlorine atoms, how many? 20 means I have to take here 10. So 10 Cl2. Clear 10 Cl2, and it is you are getting phosphorus pentachloride. Second one, what it is? In this one only take the PCl3 and treated this one with the Cl2, then what you will get? PCl5. This is the first method. Direct treated with the white phosphorus and treated with the PCl3 with the chlorine atoms, chlorine molecules, you will get the what it is PCl5. And second preparation is important from sulfuryl chloride. From what it is here? Sulfuryl chloride. SO2Cl2. See the difference here. Thionyl chloride, SOCl2. Sulfuryl chloride, SO2Cl2. Clear? So from this we can also prepare the what it is here? Phosphorus pentachloride. Treat the white phosphorus. You take the white phosphorus here. What is the formula of white phosphorus? And here this is a white phosphorus, and treat this one with the sulfuryl chloride. Then what the compound you will get? You will get the PCl5 plus SO2 will be released. Clear? So balance the equation here. How many phosphorus atoms are there? 4 means I will put here 4. And how many chlorine atoms are there? 4 into 5, 20 chlorine atoms means here I have to put the 10. So sulfur atoms, how many are there? 10. So I have to put here 10. This is about the preparation methods of which one ma here? Preparation methods of, you know, PCl5. And the next one is very important, structure. You know, structure of PCl5. Structure of which one ma here? PCl5. Clear ma? So structure of PCl5. Clear? So what is this structure of PCl5? You know that phosphorus, PCl5 means phosphorus is forming how many bonds ma here? 5 bonds. You know, phosphorus is 3s2, 3p3. Clear ma? So here there are 2 electrons here, and in the p orbital there are 3 electrons. How many unpaired electrons are there? 3. 3 unpaired electrons means it will form only 3 bonds. So that's why it will use its d orbital. In the first excited state, one of this electron will jump here. Then how many unpaired electrons are there here? Totally 5. So that's why phosphorus will form 5 bonds. Is there any lone pair electron on the phosphorus? No. So that's why all are which one here? Bond pairs only. All are which one ma? Bond pairs. So that's why, and here hybridization of phosphorus. Clear ma? In this PCl5 is a, you know, sp3d. What it is ma here? sp3d. Why? Because you know how many bond pairs are there? They have 5 bond pairs and there is 0 lone pair. So totally how many ma? 5. 5 means what it is? sp3d. 3 plus 1 4, 4 plus 1 5. Clear ma? That is. Clear ma? So whenever it is in sp3 hybridization, means sp3d hybridization, what is the shape? Trigonal bipyramidal. Trigonal bipyramidal shape. This is the shape of the molecule. What is the trigonal bipyramidal? Clear ma? So draw the structure here. Clear ma? So here triangle you write first of all. Trigonal means what it is ma? Triangle. This is a triangle. Trigonal. Clear ma? So now central atom will be there, that is a phosphorus in the middle. Clear ma? Next bipyramidal. This is one pyramid and this is one pyramid. Clear ma? Then what you will write here, you see, this is chlorine atom and here this is chlorine atom. This is chlorine and chlorine. This is totally what it is ma? The shape of trigonal bipyramidal. Now you know that here in this case, and how many, you know, these and the bonds which are present inside the triangles we will call as equatorial bonds. Equatorial bonds. What it is ma here? Equatorial bonds. Clear? How many equatorial bonds are there? 3. And this is what? Axial bonds. This is which one ma here? Axial bonds. We have 3 equatorial bonds and 2 axial bonds. Clear? But if you compare here the bond length of axial bonds and equatorial bonds, always axial bonds are longer than the equatorial bonds. Clear ma? So axial bonds are longer than what it is ma here? Equatorial bonds. Equatorial bonds. Why it is? Clear ma? You know that here what is the angle between these equatorial bonds? 120. Here also what it is ma? 120. Here 120. 3 120s. But here you see trigonal means it is a present on the plane. Clear ma? One is Cl above the plane, another Cl is below the plane. Means this bond, it is make a right angle with the all the equatorial bonds. So that's why these bonds are, what is the bond angle ma here? 90 degrees. Clear no? So that's why these axial bonds are making 90 degrees with the 3 equatorial bonds. 90 degrees means what ma? And they are close to equatorial bonds. When they are close to equatorial bonds, you know, and bond pair repulsions will be greater. Clear ma? You know that here 3 bonds are there ma. Here there are equatorial bonds, 3 are there. Among this, what is the bonds angle here? 120. But if I draw here line, it is making 90 angle, means these 2 bonds are very close to each other. When they are very close to each other, bond means what it is, ma? Electrons will be there and repulsions will be there, and whenever repulsions is there, you know, molecule become unstable. To avoid that repulsions, these bond electrons are moved away from, you know, and equatorial bonds. Then what will happen, ma? Bond length increases. That is the reason here. Clear, ma? So this is about the structure. They will ask why here, you know, axial bonds are longer than equatorial bonds. Why? Because two axial bonds are experience the, you know, bond pair repulsions with the three equatorial bonds. So that's why axial bonds are longer than the equatorial bonds. Clear, ma? So next one is here physical properties. The first one is in this, you know, I already mentioned phosphorus pentachloride is a pale yellow crystalline solid with a pungent smell. I already mentioned PCl5 is a oily liquid. Clear, ma? It is a liquid, but PCl3 is a liquid. PCl5 is a, you know, it is yellow crystalline solid. Yellow crystalline solid. Clear, ma? And you know that in the solid state it is existed as a ionic solid. Clear, ma? In crystalline state or in solid state exist as what it is, ma? Here ionic solid. Ionic solid means in the form of what it is, ma? Here ionic solid in the form of I have already discussed this one when we discussed about the reactions towards halogens. There I have discussed. So in this one it is existed as a ionic solid, PCl4 plus and PCl6 minus. Clear? In the solid state exist as ionic solid in the form of what it is, ma? Here PCl4 plus and PCl6 minus. Clear, ma? So what is the PCl4 plus means, what is the, how many bond pairs are there? 4 means what it is, ma? Hybridization, sp3. And you know there is lone pair because phosphorus is donating its pair of electron and converting to positive. So that's why what is the PCl4 plus shape, ma? Tetrahedral. Clear, ma? And this is, if you take about this, you know how many it is gaining one chlorine atom. So that's why, you know, total 6 bond pairs are there. sp3 due to means 6 no bond pairs here, the lone pairs here. So that's why you will get octahedral. Octahedral is the shape of this molecule. Clear, ma? So this is about the physical properties of which one, ma? Here and you know, phosphorus pentachloride. In the next video, so we will discuss about the chemical properties.